Our objective for this lesson is to recognize the basic shapes of different families of functions. So we're going to go ahead and summarize this by looking at each category and drawing a basic graph. So first of all, for a linear graph is a line. It has slope. It could go slope down. It could be horizontal as well, but the basic graph looks like a line. Whereas a quadratic, the basic graph of it is a parabola. Now, linear equations, they have all real numbers as their domain and range, whereas a quadratic, it has all real numbers as its domain, but it's limited on its range because it doesn't go, in this case, in this parabola, it doesn't go in the negative part of the graph for the y values. So some of them will have limited domains and ranges for these graphs. For an odd-degreed function would be if we had one side starting down and then the other side going up to it. So one side's down, one side's up, so it could start up and then down. But notice a linear function is an odd-degreed function because it's of degree 1, as one side down, one side up. An even-degreed function, on the other hand, it's going to have one side up, and then after we do the rest of the graph, it's going to have the other side also going up, or both of them going down. It could have this side and that side going down for our end behavior. That's like a quadratic. A quadratic is of degree 2. It's a second-degree function. It has the same functionality as this one when we look at the basic graph. Let's look at some of the more recent ones that we've done in Algebra 2, some of the graphs. So a rational graph, when we graph one of these, usually there's some type of asymptote. Sometimes there's a vertical asymptote. Sometimes there's a horizontal asymptote. Okay, and then our graph will oftentimes look like this, where it chases those asymptotes off to the end behavior. And then we might have a graph like this that comes down and then maybe has an open hole in the graph before it gets close to that asymptote. But notice that this has restrictions on the domain where this vertical asymptote is, and that hole in the graph, that open dot, those are restrictions on the domain, and the range, the restriction is this horizontal asymptote. Even root graphs, when we do these, they have a starting point and then they slope off. It's kind of like a sideways half of a parabola because it's the inverse function oftentimes of an even degreed function. So as a starting point, so that my domain is only in one side of the graph and my range is also only one side of the graph. Whereas an odd root, what it will do is it will complete it, but just in the other direction. It does have all real numbers, and even though it starts leveling out, it never does. It has all real numbers for its range as well, for both domain and range. Now, what we're looking at here is exponential growth and exponential decay. Exponential growth and decay will kind of look like rational graphs, but not be the same. You got to note the difference between these two. When I do an exponential growth problem, it does have an asymptote. Oftentimes it's the axis, or we can translate the axis as well for an asymptote. But what you've got to recognize is that for the domain, it does keep going on forever. So this doesn't have a vertical asymptote stopping it. It keeps going to the right. It goes up fast, but it goes off to the right. So the domain on this is all real numbers, whereas the range is just the numbers above whatever asymptote I have, in this case the x-axis. Exponential decay starts high and then it comes down low and it goes like this on my graph. So it has an asymptote here, that's the x-axis as well, or that can be moved around as well. But again, the domain is all real numbers, but the range is just above that asymptote in this case. So these are our families of functions that we've been working with in Algebra 2. You want to know what the basic graphs look like so that when you come across one of them that's been translated or stretched or shrunk, you want to know what the basic graph is so you can draw an accurate graph.